In this video, we will solve two questions that were asked by a brother Anam Umar on YouTube. The question is, consider the short-run cost function of a perfectly competitive firm given by C is equal to 2 plus 10Q plus Q square, where Q is the output and C denotes the total cost. Suppose the price of the product prevailing in the market is $16. We are supposed to find out the profit maximizing output. And next question is, consider the following production function. Y is equal to 12 under root L, K. L and K denotes the units of labor and capital, and Y is the output. We need to find out what type of returns do it exhibit. Okay, so let's go for the first question. We are being given the cost function is C is equal to 2 plus 10Q plus Q square, and it is a perfectly competitive firm. Okay, also price of the product is being given us as $16. Now for profit maximization, and let me write it here. Okay, so for profit maximization, okay, we need to find out the profit maximizing level of output. Okay, first we need to construct the profit function, and we know profit function is simply total revenue minus total cost. Now total revenue, as we know, is simply price into output minus total cost. Okay, price is being given as a $16 times Q. Okay, P into Q is 16 into Q minus total cost function is 2 plus 10Q plus Q square. Okay, solving this, we have 16Q minus 2 minus 10Q minus Q square. This is our profit, this is our profit function. Now for profit maximization, the condition is that, okay, so to maximize profit, the first order condition is that our marginal profit should be equal to 0. That means the derivative of profit function with respect to output should be equal to 0. Okay, which implies we need to take the derivative of this profit function with respect to output and set it equal to 0 to find out the corresponding level of output. Okay, so derivative of Q is 1, so we are left with 16. Derivative of a constant is 0. Derivative of Q again here is 1, so we are left with 10, minus derivative of Q square is 2Q. Simple thing, I have explained it number of times, and we set it equal to 0. Solving for Q, so we have 16 minus 10 is equal to, transposing this here, it will become positive 2Q. So 16 minus 10 is 6, or I can write 2Q is equal to 6, which implies Q will be equal to 6 upon 2, which comes out to be 3. That means profit maximizing level of output will be equal to 3. Okay, coming to the next question, that is, we are being given the production function as Y is equal to 12 under root LK. We need to find out what type of returns do it exhibit. Okay, whether it exhibits constant returns to scale, increasing returns to scale, or decreasing returns to scale. Okay, so let's rewrite this function. I can write Y, that is output, is a function of labor and capital, which is equal to 12, and this under root can be written as L to the power 1 upon 2 K to the power 1 upon 2. Okay, so this is basic manipulation, you know it very well. Now to find whether this exhibits, there are two methods. Okay, first I will go for the usual one. If we want to find what type of returns does it exhibit, let us see what happens when we multiply each input by a factor. Okay, let us say if each factor or input is multiplied by lambda. Okay, so if I multiply each input by lambda, then what will be our production function? F of lambda L lambda K will be equal to, so 12, in place of L we have lambda L this time, because we are multiplying each input by the common factor, that is lambda, and in place of k we have lambda k raised power 1 upon 2. Okay, rewriting it, it will become 12 lambda raised power 1 upon 2 L to the power 1 upon 2. Here lambda raised power 1 upon 2 L to the power 1 upon 2. Okay, so we can write it in this fashion: lambda raised power 1 upon 2 lambda raised power 1 upon 2, then we have 12 L to the power 1 upon 2, and let me write it here k. Okay, k to the power 1 upon 2, and since bases are same we can add up the exponent, so 1 upon 2 1 upon 2 becomes 1, and this is our original function, that is this f of L k is equal to so this 12 L to the power 1 upon 2 k to the power 1 upon 2 is actually equal to f of L k. Okay, now here you can see, so we have f of lambda L lambda k. What happens, what has happened here when we multiplied each input by lambda? Okay, we can see here that our output has also increased by the same factor, that is lambda. Okay, and its exponent is 1, so we can say that this type of production function exhibits constant returns to scale. And let me show it here. So in place of lambda, let us suppose each factor is, and let me write it here, f of 2L. That means if labor is doubled, and in place of lambda we have again 2, and if capital is also doubled, what will happen? So in place of lambda, again we have 2 here, f of Lk. So here you can see when each factor was multiplied by 2, okay, our production function, our output has in fact doubled. Okay, so when factors are increased by the same proportion, and if the output also increases by the same proportion, here it has been doubled, our output has also doubled. Here we say that this kind of production function exhibits constant returns to scale. Okay, so it exhibits constant returns to scale. Okay, another way would be shortcut method will be to see the exponent, since it is a standard Cobb-Douglas production function, and this exponent of L and K actually denote the output elasticity of labor and output elasticity of capital. Okay, if the sum of exponents, okay, so if the sum of exponents add up to 1, we say it is this production function exhibits constant returns to scale. Okay, if the sum of exponents, okay, if the sum of exponents is less than 1, we say the function exhibits decreasing returns to scale, and if sum of exponents is greater than 1, we say the production function exhibits increasing returns to scale. Okay, I hope I make myself clear in this video. Thank you.